UT has given us a vector problem and asks us what the answer is if we take vector A and subtract 2 times vector B. So in this unit notation, you can see that there's an arrowhead above A, and this would be a boldface X and Y with caret symbols above them. So whenever we need the negative of a vector, we just use a negative sign or reverse its direction. And whenever we need to multiply a vector, we just multiply each item in it by, in this case, a coefficient of 2. So I'm going to have 2x minus 3y, because that's vector A, and vector A is unchanged. And I'm going to add. We don't know how to subtract vectors. We know how to add vectors. So I'm going to take this and multiply what I have here by negative 2. So when I do that, oops, I need to make sure I include that negative sign. When I do, I have negative 2x, and then negative 2 times negative 2 is positive 4y. And so now A and negative 2b are ready to be combined. So you just add each one. So negative 2x and positive 2x gives me 0. So therefore I have no x in my answer. And this sum right here is 1y, or just y. So my answer is equal to y. And that is the answer to that unit notation, or that vector notation problem. A second problem I was asked to work has projectiles in it. So this says a daredevil is going to launch a motorcycle from one canyon wall and take off on a ramp inclined at an angle that they give you. And the daredevil is going to land on the other wall of the canyon. And what minimum speed is needed to reach that opposite canyon wall? And they give you a distance for it. Well, you should notice that very little information has been given. Not only do you not have original velocity, you don't know time in the air, you don't know anything about the heights of the canyon. And so the clever thing to do is assume there's no vertical displacement, in that the landing canyon wall is the same height as the takeoff wall, and go ahead and use the range equation. So in the range equation, UT or someone else has already done the clever mathematics for you. You'll find this at the bottom of the equation sheet. And so all I have to do now is solve for that original velocity. So I'm going to move over the g. So I have delta x times g, and I'll divide by the sine of 2 theta. So into my calculator, I'm going to type 12.6 because that's my x displacement needed. G is 9.8 meters per second squared in this problem. And then I'm going to divide by the sine of, and be careful here, because this is where I need to double my angle, 2 times 14.5 degrees. So making sure that your calculator is not in radians from calculus class, go ahead and type all those things in. And remember, at the end, you have to take the square root. And so when you do that, when you finally take the square root, you're going to get 15.96, etc. More figures, I'm sure, on your calculator, especially if you're Quest crazy. Hope this helped. Bye-bye.